Assalamualaikum warahmatullahi wabarakatuh to Dr. Mama Aifaa bin Mama Ariff and Dr. Syed Zahurul bin Islam. My name is Izzatty binti Shahrom. I will present about my final year project which entitled The Study of Charging Scheme for Lithium-ion Battery System. I am supervised by Dr. Jabbar Fattah bin Yahaya. Introduction. For introduction, this project describes charging scheme for lithium-ion battery. Design of charging scheme made for 50-volt 10 Ah lithium-ion battery. An enhanced basic charging scheme named as boost charging scheme with constant current, constant voltage concept. And another improved of charging scheme named as pulse charging scheme were proposed. Simulation and mathematical calculation are presented in this paper. A boost converter with PI controller are involved in construct a boost charging scheme with CCCV concept. For pulse charging scheme, half bridge inverter with PI controller included in circuit to produce the charging pulse and discharging pulse alternately. All these purpose charging schemes are simulated using MATLAB Simulink. Result obtained in some parameters such as state of charge, SOC, voltage, current, cell temperature and charging time. Estimation for fully charged battery also shown in this report. Comparison between two charging schemes proposed was discussed in terms of efficiency and performance. Objective and scope. There are two objectives to achieve by the end of the project. The first one is to design this and simulate two charging schemes for lithium-ion battery using MATLAB Simulink. And the second one is to analyze the difference between two charging schemes for lithium-ion battery in terms of charging duration and temperature of battery during charging phase. The scope for this project is design a basic charging scheme for lithium-ion battery named as boost charging scheme with applied constant current, constant voltage concept. Number 2, design another alternative charging scheme for lithium-ion battery, which is pulse charging scheme. The third one is simulate these two charging schemes using MATLAB Simulink. Number 4, proposed charging scheme is only for a 50-volt 10 Ah lithium-ion battery without any battery management system BMS applied. Analysis made according to SOC, voltage, current, duration of charging, and temperature of lithium-ion battery. The last one is estimation of charging time and temperature of lithium-ion battery from 0 to 100%, which is full charge, and 50% to 100% full charge. Research gap. And for this section, this is the paper that I refer to in order to complete this project. Okay, the first one is a paper written by S. George, M.R. Hassan, A. Mahmoud, and the title of this paper is Propose a Technique to Design a Boost Converter Best Charger and Analysis of the Power and Efficiency. The method used is proposing a boost converter to charge a battery. There is a simulation about this and adjust the duty cycle, and then the result obtained was analyzed. So the outcome of the study is we can see that a boost converter are able to charge a battery, but we also can conclude that the higher duty cycle will decrease the efficiency because it may cause high of power loss. And the next one is photovoltaic power DC boost converter based on PID controller for battery charging system. This paper is written by M. Irwanto, WZ Dio, B. Ismail, and H. Baharudin, R. Julianga, H. Alam, and Masri. So the method that used in this paper is charge a lead-acid battery with boost converter and PID controller using MATLAB Simulink. The circuit supplied by PV photovoltaic module. So the outcome of this study is result can see in SOC state of charge, battery current, and battery voltage. The increment of SOC is 0.13% in 1 second of charging. All in all, charging duration needed to fully charge the battery is 1 hour, 3 minutes and 37 seconds. Impact of periodic current pulse in lithium-ion battery performance. The method used in this project is to study about the effect of current pulse charging to a battery in terms of performance. Next, the comparison between CC charging and proposed current pulse charging are discussed. The outcome is in few minutes of charging test, pulse charging give more positive impact to the battery, which is differ from CC charging. In brief, charging a battery with proposed pulse charging give a better performance. The next one is a design of an optimal battery pulse system by frequency varied technique. This paper written by Liang Ruiqing. The method used is to apply pulse charging to lithium-ion battery. Simulation and hardware testing are conducted with different frequency of pulse. Also, pulse charging has been compared with conventional current method in terms of efficiency. The outcome of this paper, variable frequency pulse charging method succeed to improve more than 10% of charging time compared to the fixed frequency pulse charging. And another one is pulse charging also provide 24% faster charging speed compared to CCCV charging boost charging scheme with CCCV concept. Okay, the first one is this is the figure of a block diagram about our charging scheme. This charging scheme consists of a voltage source, which is the input source, and then we'll connect it to the boost charging scheme with CCCV concept, and then the system will have a controller, which is PID controller, and lithium-ion battery as load. Definition of CCCV concept can be divided into two. The first one is CC. In beginning of charging, battery charged with CC concept. For example, with constant current, the constant current is 5 ampere. The battery will charge the battery with 5 ampere until the SOC reach to 80%. At the same time, the voltage from the charging circuit will increase until it achieves the voltage limit. We can also see the illustration of this definition for definition of concept for CCCV. Okay, next is CV. CV we can define as when the SOC of the battery is 80%, the charging circuit will charge the battery with constant voltage, for example 10 volt. The charging scheme will charge the battery with constant volt until it fully charged. The current will decrease to minimum current but still supply to the battery. At this moment, the state of charge for the battery will increasing until fully charged. So, next is the definition of boost charging scheme. Boost charging scheme, known as a charging circuit combined with boost converter that act to step up the input power to the higher value and then supply to the battery. The advantage of this scheme is to provide a safe charging scheme where it keeps the battery and the system from any undesired thermal condition, which such as overheat. Okay, this is this converter circuit. This circuit simulated using dialect simulating to determine the output waveform as stated in theoretical for boost converter. This circuit designed for 21 volt of voltage source, and the expected output of this boost converter is 42 volt. The output power is 48 watt with frequency 20 kHz respectively. This scope is for to display the current from the system, and this scope is used to display the waveform for the output voltage. The pulse charging generator works to produce the pulse in sinusoidal. Okay, as you can see here, the basic component of boost converter circuit is voltage source, inductor, MOSFET, capacitor, and resistor. And also diode. So this is the boost charging scheme with CCCV concept circuit. So the circuit is simulated using the MATLAB Simulink. So this charging scheme simulated in order to determine the duty cycle and resistance that suit with uh, this this scheme. And then we record and observe, analyze the performance of the battery, which is SOC, current output, voltage output, cell temperature during the charging. So this is the controller that we use. In this controller, we have a PID controller that function to control the output based on three input. The first one is duty cycle. The second one is current reference and output current of the system. So this one is the voltage source, VDC. So this is the boost converter circuit that connected to the battery, lithium-ion battery. Okay, this is pulse charging scheme. This is the profile for pulse charging scheme. As we can see here, the charging scheme will supply the charge pulse, and in between the charging pulse will have the interruption of discharging pulse. So the definition of fast charging can be said as charging a battery with charge pulse and interruption of discharging pulse. Discharging pulse are known as rest or relaxation period. So this is the block diagram for a pulse charging scheme, which consists of voltage source. A voltage source acts as input supply to the pulse charging scheme, and then it will connect it to pulse charging scheme, and a PID controller act as a controller, and also the most important one is the lithium-ion battery. So in pulse charging scheme, we have the half bridge inverter. Why we need half bridge inverter in this circuit? Half bridge inverter is known as electronic circuit that function to convert DC power to AC power, which means produce a pulse with variety of frequency and voltage. So this pulse charging scheme can provide basically two advantage, which is the first one, it can improve the state of health and aging rate of the battery, because uh, this charging scheme put less pressure to the battery, which is known as relaxation period. So if the battery less pressure, the state of health can be maintained and the range and the aging rate of the battery will become slower. It also can charge the second one, it also can charge the battery more faster because it use high current, and it at the same time it give the battery reaction time, so the battery can cool down during the charging process. Fast charging scheme. This simulation made to determine, analyze, and observe the output of battery, which is SOC, state of charge, output current, output voltage, ambient temperature, and cell temperature. Ambient temperature will be constant at 20 Celsius. So this fast charging scheme is designed to for 10 ampere hour lithium-ion battery. Next is this fast charging scheme consists of a half bridge inverter, which function to produce a pulse, and then the supply that we use is voltage source, and this is the controller. The controller functions same as boost charging scheme, where it works to control output based on three input, which is duty cycle, reference current, and output current of the system. So the system can produce better and stable output. This is a saturation block that acts to produce an output signal in between range of upper and lower boundaries that we set. This is PID controller. This is repeating a sequence that works to help the system produce a periodic scalar signal with a specific waveform that applied. So basically this is the circuit that I used to complete this project.